30,000. That's the grim tally of annual traffic fatalities at urban intersections across major U.S. cities. And every 16 minutes, another accident rips through one of these critical junctions. These aren't mere fender benders. They're the choke points where city life grinds to a standstill. Old-school intersections are surprisingly dangerous, leading to 40% more collisions than their updated counterparts. Consider this: 80% of urban delays stem from these bottlenecks, costing you 55 hours each year. That's almost a full week of your life vanishing into gridlock. Between 2010 and 2020, accidents at these urban crossings jumped by 15%. These outdated designs are simply not cutting it. Nationwide, over 2,500 minor collisions happen every single day at these same junctions, racking up millions in damage. This persistent chaos wears down millions of daily commuters. Losing 70 hours annually to traffic lights alone? That's over 2 work weeks gone for the average American, a sheer drain on productivity. Think about human reaction time: 1.5 seconds. That's roughly the span of closing your eyes and at 30 miles per hour, hitting something. Absurd. A standard 4-way intersection presents 32 distinct points where things can go wrong. This layout, essentially unchanged for decades, churns every vehicle into a blender of potential conflict. In 2022 alone, intersection crashes accounted for 27% of all fatal accidents. In a way, it's evolution meeting the traffic light, and the traffic light meeting chaos. Congestion at these vital junctions bleeds the U.S. economy for $160 billion annually, a mix of lost productivity and wasted fuel. On a 10-mile urban drive, you might encounter 20 intersections. That's 2 conflict zones per mile, demanding your constant attention. Meanwhile, urban populations are climbing 1. Back in 2005, a 3-year design sprint birthed a wild idea for intersections: the diverging diamond interchange. Its core concept: flip the traffic lanes. Imagine this: it slashes 16 potential conflict points in typical designs down to just 2. Instead of waiting to cross oncoming cars for a left turn, you simply shift to the wrong side of the road. This creates direct, protected left turns, massively cutting down on severe collision risks. Simulations proved it could slash serious accidents by a staggering 30%. Think fewer T-bones, more peace of mind. Planners zeroed in on the city's worst bottlenecks: intersections clogged with 45,000 cars a day, places that were essentially accident magnets. So, in a leap of faith, Springfield, Missouri greenlit a pioneering pilot project, an $18.5 million gamble, enough to build about 30 new urban parks. The big goal was a 20% drop in injury crashes within 3 years. This wasn't just hope, they needed hard numbers. Each diverging diamond features special contraflow lanes, retime signals, and obvious overhead signs to guide everyone. It's a choreographed dance of concrete and light. Initially, people were pretty wary. Drivers faced a significant learning curve, prompting over 5,000 brochures and extensive awareness campaigns. For the first month, intersection ambassadors were stationed on site, essentially traffic guides for confused motorists. It's this kind of audacious urban planning that's really needed. 6 months in, early reports showed a 15% dip in overall collisions. Turns out, drivers adapted quicker than expected. Peak hour congestion eased by 25%, shaving 5 minutes off commutes. Traffic engineers are calling the diverging diamond a win for smart design, able to handle a lot more traffic. Engineers poured 12,000 cubic yards of concrete, building intricate roadways that defied gravity. 1,500 tons of high-strength steel rebar reinforced this immense structure, ensuring its durability. The entire meticulous process of ramp building and signal integration spanned 28 months, during which hundreds of complex maneuvers were completed across round-the-clock shifts. Underneath, excavators moved over 100,000 cubic yards of soil, enough for 10-story foundations. Each roadway section featured up to 6 pavement layers, 10 feet deep. Over 300 smart sensors were embedded, creating a data network rivaling a small town's. Intricate drainage systems managed 50,000 gallons of stormwater per hour, preventing floods. while 200 LED luminaires provided night visibility, consuming 60% less energy. Lifting massive pre-stressed concrete girders, some weighing 80 tons, required specialized cranes. And get this, 75% below national construction safety standards was the target, and they hit it. That's less than your average home renovation site. Materials came from 150 regional suppliers, cutting transport emissions by 25%. During construction, a logistical ballet unfolded as temporary rerouting handled 1.5 million vehicles weekly. Beyond its function, 2 acres of native landscaping integrated the structure visually. Today, maintenance crews perform routine checks, ensuring its continued efficiency. New intersection designs are slashing left-turn accidents by more than half, proving their life-saving power. Overall, crashes at these redesigned spots dropped by 30%, making journeys much safer for millions. Traffic delays also fell by a solid 20%, saving commuters thousands of hours every year. These safer intersections are now adopted in over 30 countries worldwide, fundamentally reshaping how we move through cities. Left-turn collisions, often the most severe, saw a 55% reduction. Average speeds through these junctions actually increased by 10 miles per hour, translating to smoother trips for 200,000 daily commuters. Turns out gridlock was just bleeding money. With this success, more than 150 cities globally have adopted similar advanced intersection designs. Public surveys show an 80% approval, even with initial doubts. One flagship diverging diamond interchange, after a decade, still holds its 60% accident reduction rate. Driver confusion? It mostly vanished. Most people figured it out in less than a week. It's faster than learning most new software. Future smart cities will have these intersections woven into their very fabric, and scientists are still refining the models to push urban safety even further. The legacy? Millions of lives saved, and a global pivot towards safer, more efficient urban travel. It's a quieter, more predictable urban pulse.